Okay, this term is going to be about how life formed on the planet. It's going to look at evolution and how species and populations evolve. So we're going to start off looking at biogenesis, which literally means the creation of life. So, in the principle of biogenesis, it says that all living things come from other living things. That seems like a pretty reasonable idea to us now, but of course, like many things, we didn't used to think like that. Before the 17th century, however, it was widely thought that living things could also arise from non living things in a process called spontaneous generation. The reason why they believed in spontaneous generation is because they would see things like maggots magically appearing on rotting meat. And they would also see fish appear in ponds that had been dry the previous season. So they thought that the meat, which obviously is dead flesh, would create these maggots. And they thought that the mud actually created the fish. So, to learn more about spontaneous generation, scientists started to perform controlled experiments. So, there's three experiments I'm going to talk about. The first one is by Reddy. So, in Reddy's experiment, he was looking at the whole maggot meat thing, and he noticed that after a time, the maggots would turn into these little oval cases, which we now know are the pupa stage, and flies came out of these oval cases. So he also observed that the maggots seemed to come from where adult flies had previously landed. So he tested whether the flies came from the rotting meat, um, or whether they came from the flies. So you can see from the diagram here, we have the control group. If you remember back to when you learned about how to design experiments, you have a control group where that's kind of what you use as your standard to compare when you change the independent variable, then that's called your experimental group. So if you need some review on that, then let me know and I can do another video reviewing how experimental design works. So your control group is where you're not changing anything. So his control group was an open jar. The experimental group, the independent variable that he changed was covering the jar. And so in experiment, you have an independent variable and dependent variable. So the independent variable is the one that you change, and then your dependent variable is the one that obviously is going to change or not change depending on your independent variable. So in his control group, he left the jar uncovered, and his experimental group, he covered it to see whether or not maggots would develop on, apparently he used a steak, or whatever kind of meat that he used. So in the control group, you see that it's not covered, so the adult flies were able to fly into the jar. Excuse me. The adult flies were able to fly into the jar, and then maggots would form on the meat. But for the experimental group, when you covered the jar, which means that flies are not able to enter the jar, there were no maggots formed. So this was the first step to debunking or disproving the spontaneous generation theory. Okay, the next experiment we have is by, assuming he's Italian, by his name, Spallanzani. Spallanzani. So around the same time as Reddy, there were other scientists who were using a brand new tool, the microscope. The microscope showed that the world is teeming or full of tiny little creatures like you see in the GIFs there. People back then concluded that these creatures spontaneously came from what they called a vital force, poof, in the air. So Lazzaro Spallanzani designed an experiment to test this hypothesis of spontaneous generation. He hypothesized that these tiny creatures did not arise or form from the air, but rather came from other microorganisms. Now, he knew that microorganisms grew easily in food. In this case, the food is broth from boiled meat. I think we used to eat a lot of meat in the day. And he reasoned that boiling the broth would kill all of the microorganisms in the broth, on the glass, and in the air inside of the flask. So his experimental group is that he would boil the broth and then he would seal the flask shut. And he sealed the flask by melting the neck on the flask. For his control group, you can see that he boiled the broth, but then left the flask open. So what were his results? Okay. So on the top, we have his control group. So the broth was heated up. So that basically kills anything in the broth, in the air, in the flask, and on the glass. But the flask is left open. After a period of waiting, we saw microorganismal growth. We had microorganisms. And his experimental group, he also boiled the broth, but afterwards he sealed the flask. You waited, there was no growth in the sealed flask, but once you open the flask, there was growth. Even after this experiment, some people still disagreed with the results. They actually said that Spallanzani heated the flask for too long and destroyed the vital force that was in the air. And because the vital force was destroyed, life could not be created. This opposition to these experimental results lasted for another century. So even though you have scientists that are performing these experiments that are disproving the theory of spontaneous generation, people still didn't want to believe. Finally, we have Louis Pasteur, who is probably one of the most famous biologists besides Charles Darwin and a few others. So the mid 1800s, we started this idea in the 17th century, which was the 1600s. Now, 250 years later, we're still arguing about whether or not spontaneous generation is how life is formed. It's kind of strange that we would think that. That's only 200 years ago. The Paris Academy of Science offered a prize to anyone who could help clear up the controversy over spontaneous generation. And Louis Pasteur was the winner chicken dinner. So he wanted to address the issues that people had with Spallanzani's experiment. So he made a brand new kind of flask that has that curved neck that you see there. And what's so special about that curved neck is that it allowed air inside the flask to mix with air outside the flask. So now you can't have people arguing, you destroyed the vital force. So at the same time, the curved neck prevented solid particles like microorganisms from coming into the flask. So his experimental design actually addressed everyone's issues, especially when you have the people with the vital force crowd. It addressed their issue with Spallanzani supposedly destroying the vital force by heating the broth for too long. Doing it this way, Pasteur basically can say, well, look, if the vital force really is the reason for life being created, then it can still mix with the vital force in the outside air. So, right, so how he did his control group and his experimental group. His control group was basically leaving the neck on the flask. So he boiled the broth and he waited and there was no growth. So this basically then completely kicks the spontaneous generation, life, vital force, whatever, crowd to the curb, because he's like, look, your air in the flask can mix with air outside the flask and there's still no growth. But for the experimental group, what he did was he broke that special neck off. And as soon as he broke the special neck off, then you got microbial growth. After this experiment, believers in spontaneous generation finally gave up. And finally, at last, the principle of biogenesis became the cornerstone of biology.